Ever wondered how your camera flash works? Or how your computer stores energy even when unplugged? The secret lies in a tiny but powerful component, the capacitor. Today, we'll explore what capacitors are, how they work, and their amazing applications. A capacitor is essentially an electronic component that stores electrical energy in an electric field. It's made up of two conductive plates separated by an insulating material called a dielectric. Think of it like a tiny rechargeable battery, but with a twist. The key difference between a capacitor and a battery is that a capacitor stores energy electrostatically, while a battery stores it chemically. Capacitors come in various shapes and sizes, each designed for specific applications. You might see ceramic, electrolytic, or film capacitors in your devices. The principle behind a capacitor's operation is based on the accumulation of electric charge. When a voltage is applied across the plates, electrons flow onto one plate, making it negatively charged. The other plate loses electrons, becoming positively charged. This separation of charges creates an electric field between the plates. The stronger the electric field, the more energy the capacitor stores. The dielectric material plays a crucial role. It prevents the charges from directly flowing between the plates, allowing the electric field to build up. Different dielectrics have different permittivities, which affect the capacitance. The amount of charge a capacitor can store for a given voltage is called its capacitance, measured in farads. F C is equal to Q divided by V, where C is capacitance, Q is charge, and V is voltage. When a capacitor is connected to a voltage source, it starts charging. Electrons flow onto one plate, and the voltage across the capacitor increases until it reaches the source voltage. This is the charging phase. Once charged, the capacitor stores energy. When the voltage source is removed or a load is connected, the capacitor discharges. The stored energy is released, and electrons flow from the negatively charged plate to the positively charged plate until the plates are neutral. The rate of charging and discharging depends on the capacitance and the resistance of the circuit. Capacitors are essential components in countless electronic devices. Here are a few key applications. Camera flash. Capacitors store energy and release it quickly to power the flash, producing a bright burst of light. Power supplies. They smooth out voltage fluctuations, ensuring a stable power supply for sensitive electronic components. Audio systems. Capacitors are used in filters to separate different frequencies, improving sound quality. Touchscreens. They detect changes in capacitance caused by your finger, enabling touch input. Filters. Capacitors are used to block DC and allow AC signals to pass or vice versa. Timers. Capacitors with resistors are used in timing circuits. So, the next time you use your smartphone or hear music from a speaker, remember the humble capacitor, silently working to store and release electrical energy. It's a small component with a big impact on our modern world. Thanks for watching. Don't forget to like and subscribe for more electronics explanations.